Okay, now that you know how to add polynomials, subtracting polynomials is going to be a cinch because there's only one little item of information that you need to add to what you already know. And what you already know is if you have a number like 6 minus 7, that is exactly the same. That subtraction expression is exactly the same as this addition expression. So 6 minus 7 is exactly the same as 6 plus negative 7. Negative 7 is called the additive inverse of 7. So all you have to do is change this sign and then change this sign here, and you have exactly the same result. Both of these result in the same value. So if you have a number or an expression and you want to find the additive inverse, you just change the signs. For example, 2a minus 3 is exactly the same as 2a plus, and you should know the answer here, you should know what I'm going to write in, plus negative 3. Those two expressions are identical. So when we look at polynomials, it's going to be the same. Here we have two polynomials and we're subtracting them. So all we have to do is change this expression over here to its additive inverse. And then we're going to have an addition question. So I'm going to change this to adding, and then I'm going to change this to its additive inverse, this to its additive inverse, and this to its additive inverse. Now I have a simple polynomial, well, not that simple, but a polynomial expression, two polynomial expressions that I'm going to add together, and I can do it in one of two ways. I can do it vertically or horizontally, or I can do it vertically. I'm just going to try it vertically right now. So I just write this one underneath. And it's getting a little messy here, but I can still see I've got 2y minus 1y, so that's just going to be y squared. I've got negative 7 minus negative 2y, that's going to be negative 9y, and I've got positive 3 minus 1, so I know that this is going to be negative, we're going to subtract, it's going to be a positive 2 there. Okay, 3 minus 1 is 2. So those are the steps involved, and I'm just going to show you one more example. And here again, a subtraction question. The first thing I'm going to do is change this into its additive inverse, and I'm going to change this into negative 5a squared, and this into negative a, and this into positive 3. And now I can just add them together. So I can go 3a squared, and I'll just put it underneath here. I know it'll get a little messy, but hopefully you can figure out what I'm doing. Line them up. I've got 3 minus 5, that's going to be negative 2a squared. I've got negative 2 minus a, that's going to be negative 3a. And I've got 4 plus 3, that's going to be 7. So just one more time. If you remember the additive inverse, subtracting polynomials becomes the same as adding them, and you know how to add them, so you can easily subtract them. And one other thing to think about is if you've got a polynomial like this, minus 3x squared plus 2x plus 4, it's also the same as, and this is one thing you can think about too, it's also the same as negative 1 times whatever inside the brackets. So then just using your distributive principle, you distribute the negative 1 over to that, and you get negative 3x squared. You distribute it over to that, and you get negative 2x, and you distribute it over to that term, and you get negative 4, which is exactly the same as the additive inverse of, whoops, I need to have a negative sign here, because negative 1 times 3x squared would be negative 3x squared. So that's the reason why that additive inverse works like that.